Higher Secondary Examination 2017 Subject Mathematics Full Marks 100 Pass Marks 33 Time 3 hours 15 minutes 15 minutes are given as extra time for reading questions. Ahenba minitra madi question panabagi damaktani. Attempt all questions. The figures in the right margin indicate full marks for the questions. Ye thangma nakanda lairiba figure sing asina question sing asigi full marks sing tae. For question numbers 1 to 6, write the letter associated with the correct answer. Question 1 dagina 6 fawbadi achumba answer adugi mapada laiba letter adu iramu. Question number 1. The relation R on the set of rational numbers defined by R equal to order pair x, y such that x, y belongs to Q and x is less than y is reflexive, symmetric, transitive, none of these. We have to select C as. Question number 2. The principal value of 10 inverse of 10 to 35 pi by 3 is. Which one is true? Correct answer is D. 10 inverse of 10th of something. This something can be written as 12 pi minus pi by 3 and whose expansion is minus 10th of pi by 3 and 10th of 60 degree is root 3 which is minus pi by 3. Therefore the correct answer is D. If the function f of x equal to this when x does not equal to 0 whose value is k when x is 0 is continuous at a point x equal to 0, then the value of k is. We have f of 0 equal to limit of sine of thrice x by 4x x tends to 0 which can be written as limit of sine of thrice x by thrice x into 3 by 4 x tends to 0 and whose value is 1 and into 3 by 4 is 3 by 4, but f of 0 is equal to k equal to 3 by 4. The correct answer is B. For question number 4, the equation of the Norman at the point x1 y1 to a curve y equal to f of x may be written as. The equation of the Norman. The correct answer is D. If the value of this definite integral is I, then the value of A is 2313 by 2. Correct answer is A. Is thrice x square whose integral is x cube, and we get a 0 a cube equal to I, that is A equal to 2. Question number 6. The distance of the point with position vector A from the plane R vector dot n vector equal to Q is a vector dot n vector minus Q by modulus of n vector. Correct answer is B. For question number 7, when is a binary operation asterisk on a set S said to be associative? A binary operation asterisk on a set A is said to be associative if asterisk of B asterisk C equal to asterisk of B asterisk C for all A, B, C belongs to A. Define transpose of a matrix A. 1 mark. The transpose of a matrix A is the matrix obtained by interchanging the rows and columns of the matrix A. Is Lagrange's mean value theorem applicable to the function f of x equal to modulus of x in closed interval minus 1, 1? Lagrange's mean value theorem. No, as f of 1 whose value is 1, f of minus 1 whose value is also 1. The value of these two ends are equal, therefore it does not satisfy one condition. Question number 10. The length and breadth of a rectangle are increasing at the rate of half centimeter per second. Is how fast is the perimeter of the rectangle increasing? We have P equal to 2 times of L plus B. Therefore, dP by dt equal to 2 times of dL by dt plus dB by dt. The value of dL by dt is half dB by dt whose value is also half. We get 2 centimeter per second. Thus, the perimeter of the rectangle increasing at the rate of 2 centimeter per second. Question number 11. Write in words the formula of integration by parts. The integral of the product of two functions is first function unchanged into integral of the second function minus integral of product of differential coefficient of the first function and integral of the second function. Give a standard form of a linear differential equation of first order. The most general form of a linear differential equation of first order is dy by dx plus p of y equal to q, where p and q are constants of functions of x only. 13. Define scalar product of two vectors a and b. The scalar product of two non-zero vectors a and b denoted by a dot b is defined as a dot b equal to magnitude of a into magnitude of b into cos theta, where theta is angle between a and b, and the theta is lying between 0 to pi, including the two ends. Question number 14. If alpha, beta, gamma are the direction angles of a line, then prove that sin square alpha plus sin square beta plus sin square gamma equal to 2. 1 mark. We have learned that cos square alpha plus cos square beta plus cos square gamma equal to 1 is alpha, beta, gamma are the direction angles of a line. So, sin square alpha plus sin square beta plus sin square gamma. Sin square alpha can be written as 1 minus cos square alpha is sin square alpha plus cos square alpha equal to 1. Similarly, we have put this, we have also put this. And 1, 1, we get 3. Combining these three terms, we get this, whose value is found to be 1. 3 minus 1 is 2. Hence, proof. Question number 15. Write the expression for the shortest distance between the line this and this in terms of the vectors a1, a2, b1, b2. 1 mark. The distance d is a2 minus a1 dot b1 vector cross b2 vector, all divided by magnitude of b1 vector cross b2 vector. Question number 16. Define mean or expected value of a discrete random variable. Suppose a discrete random variable x assumes the values x1, x2, x3, xn with respective probabilities p1, p2, p3, pn, such that summation of pi from 1 to n is 1. Then the mean or expected value of x is defined by x bar, or expectation of x equal to summation of pi xi starting from 1 to n. Question number 17. Show that the function f from R to R defined by f of x equal to twice x minus 1 by 3, x belongs to R is 1, 1 and on to 3 marks. Here the f equal to this. Let x and y belongs to R such that x does not equal to y. Multiplying both sides 2 and subtracting 1 and dividing all both sides 3, we get this, which these two terms are not equal. Which is equal to f of x, which is also equal to f of y. These two are not equal. By definition of 1, 1, we have f is 1, 1. On to let y equal to twice x minus 1 by 3. Y belongs to our codomain. Here R is codomain and x belongs to R. Here R is domain. Solve x, we get this, which is always x is always real number for any real value of y. F implies f is onto. Hence f is 1, 1 and onto. Question number 18. Using properties of determinants, prove that the value of this determinant is a plus b plus c whole cube. 3 marks. Here this. New row 1 becomes, by adding row 1 plus row 2 plus row 3, we get this. Taking out a plus b plus c from first row, we get this. And subtracting first column by second column, we get new first column, which has 2 zeros. Therefore, we have to expand in this column, having maximum zeros. Expand in first column, we get this. And simplifying, a plus b plus c whole cube. 19. Prove that a square matrix A is invertible if and only if A is a non-singular matrix. 3 marks. Let A be an invertible matrix of order n and I be the identity matrix of order n. Then there exists a square matrix B of order n such that product AB equal to BA equal to I. Now product AB equal to I, which gives modulus of product AB equal to modulus of I. Then determinant of A into determinant of B into identity matrix की determinant 1. This. Then product of this, which product of two numbers is 1, therefore determinant of A does not equal to 0. Hence A is a non-singular matrix. Conversely, suppose A is a non-singular matrix, then determinant of A does not equal to 0. Now A into adjoint A into A equal to determinant of A into I. Divide in its term by determinant of A, as determinant of A does not equal to 0. Then A into this bracketed expression into A equal to I. This shows that where AB equal to BA equal to I, where B equal to 1 by determinant A into adjoint A. Thus A is invertible and A inverse equal to 1 by determinant A into adjoint A. Define a differential equation, its order and degree. 3 marks. Differential equation. An equation involving derivative or derivatives of the dependent variable with respect to independent variable or variables is called a differential equation. Derivative natraga derivatives yawa equation amabu differential equation kawe. The order of a differential equation is the order of the highest order derivative of the dependent variable with respect to the independent variable involved in the given differential equation. Degree. The degree of a differential equation when it is a polynomial equation in derivatives is the highest power of the highest order derivative involved in the given differential equation. Question number 21. Find the value of lambda for which the vectors this and this are coplanar. 3 marks. These 3 vectors are coplanar. It is given. We have to find out lambda. For coplanar vector this and this, their scalar triple product is 0. That is, this value is 0, whose value is determinant of A1, A2, A3, second row B1, B2, B3, third row C1, C2, C3, and whose respective values are this. And expand in first row we get this, from which we have to solve lambda equal to 26 by 25. This is the required value. Question number 22. If the mean of a binomial distribution is 3 and variance is 3 by 2, find the probability of at least 5 successes. Binomial distribution amagi mean amasung variance to mathang china 3 amasung 3 by 2 ni yamdrabada 5 successes ki probability putu haibani. Here mean is 3 and variance is 3 by 2. For binomial distribution, mean is equal to NP and variance is also equal to NPQ. Therefore, NP whose value is 3 and PQ whose value is 3 by 2. Solving these two equations, we get Q equal to half and P equal to half. Also N equal to 6. Therefore, required probability is P of x greater than or equal to 5, which is equal to P of x equal to 5 plus P of x equal to 6. Their respective values are 65 Q into P to the power 5 plus 6C6 P to the power 6, whose respective values are given. We have 7 by 64. Question number 23. Prove that sine inverse of 4 by 5 plus sine inverse of 5 by 13 plus sine inverse of 16 by 65 is pi by 2. 4 marks. 11th side. Sine inverse of 4 by 5 plus sine inverse of 5 by 13 plus sine inverse of 16 by 65. Using addition of sine inverse x, that is, we have to use this formula: sine inverse of x plus sine inverse of y, whose value is sine inverse of x into root over y square plus y into 1 minus x square. Use this formula. We get this. After simplification, we get this, and again simplify. Sine inverse x is equal to cos inverse of root over 1 minus x square, whose value is this, whose value is also this. These two values are equal. This is an identity whose value is pi by 2. Hence right hand side. Question number 23, or if sine inverse x plus sine inverse y plus sine inverse z equal to pi by 2, prove that x square plus y square plus z square plus twice x y z equal to 1. 4 marks. Sine inverse x plus sine inverse y plus sine inverse z equal to pi by 2. Sine inverse x change into cos inverse of root over 1 minus x square. Similarly for this, transfer this on the right side, we get this. Again, addition cos inverse x plus cos inverse y, applying that formula, we get this, which is equal to what? This is pi by 2 minus sine inverse of z equal to cos inverse of z. And cancelling cos inverse, we get this. Transfer this on the right side and squaring, we get this. Expand and cancelling equal terms on both sides. Lastly, we get this, which was to be proved. Question number 24. When is a function said to be derivable at a point? Prove that if a function is derivable at a point, then it is continuous at that point. A function f is said to be derivable at x equal to a if limit of f of a plus x minus f of a by x tends to 0 exists finitely. It is given that f is differentiable at c. So, limit of f of x minus f of c by x minus c, x tends to c, equal to f dash of c. We have f of x minus f of c equal to this. Taking limit as x tends to c on both sides, we get this. For this, we have this. For this, we have this. And for this, its value is f dash c, and which is a polynomial. Put x equal to c, we get c minus c is 0. So, finite number into 0 is 0. Then limit of f of x as x tends to c equal to f of c. This shows that f is continuous at x equal to c. If sine x whole to the power y equal to x plus y, prove that dy by dx equal to this expression. 4 marks. Taking log on both sides, we get this. Y times of log of sine x. Differentiating both sides with respect to x, we get y into d by dx of log of sine x is 1 by sine x into cos x, plus second function log of sine x remains unchanged into derivative of first function, that is dy by dx, equal to log of something whose derivative is 1 by something into derivative of x plus y with respect to x is 1 plus dy by dx. Transfer dy by dx term containing dy by dx in left side and other term which does not contain dy by dx on the right side, and simplify, we get this. Solve dy by dx, we have reached the final result. Question number 25. Or if sine inverse of y equal to log of x, prove that this equal to 0. 4 marks. Here, sine inverse y equal to log x implies y equal to log or sine of log x. Sine of log x. Differentiating both sides with respect to x. For this, sine of something whose derivative is cos of something into d by dx of log x, that is 1 by x. Multiply x on both sides, we get this. Again, differentiating on both sides with respect to x. Use product rule here. Put first function and derivative of dy with dx with respect to x is d square y by dx square, plus second function dy by dx remains unchanged into derivative of x with respect to x, which is 1. And for this, cos of something is minus sine of something into d by dx of log x is 1 by x. Multiply on both sides x and transfer the term in right on the left side, we get this. And sine of log x is replaced by its original value y. We have the final result. Question number 26. Draw a rough sketch of the curve x squared by 9 plus y squared by 4 equal to 1 and find the area enclosed by the curve using integration. 4 marks. Here the curve is this. Solve y from this. We have y equal to plus minus 2 by 3 times of root over 9 minus x squared. The curve is symmetrical about both axes as x The power of x is even, y is also even. Therefore, the curve that is ellipse is symmetrical about both axes, whose center is at the origin of the coordinate axis, as in this picture. Find the area enclosed by the curve using integration. There are four identical portions. Therefore, require area 4 times area of OAB, area of this shaded region. 4 times the area of this shaded region gives the area of this closed curve that is ellipse, and whose integration is y dx from 0 to 3, 0 to 3, 0 to 2. This is x-axis, 0 to 3. Why it is 0 to 2? 0 to 3. It will be 3. Why it will be 2? X is 3. It must be 3. It must be 3. It must be 3. And whose integral is this? Whose integral is this? And put upper limit 3, x replaced by 3, we get this, and x, put x equal to 0, we get this. Simplify, we get 6 pi square units. Question number 27. Solve the differential equation given that y equal to 1 when x equal to 1. 4 marks. The given equation is this. Solve dy by dx, we get this. This is a homogeneous differential equation. Put y equal to bx and dy by dx equal to b plus x dv by dx, we get b plus x dv by dx equal to minus y minus b minus b square. So apply separation of variables, we get this. 1 by b times of b plus 2 db plus 1 by x dx equal to 0. Integrating both sides and balancing, we get this. For constant of integration, we have put log of c. Integrate, we get this. And taking square root on this and apply product rule for log, we have this. Put y by bx and solve, we get this, which is the general equation, general solution of the equation. When x equal to 1, y equal to 1, we have k equal to 1 by 3. Therefore, the last or the final solution is this. Thrice x square y equal to y plus twice x. For question number 28, show that the perpendicular distance of the point C from the line joining the points A and B is modulus of B cross C plus C cross A plus A cross B whole divided by modulus of B minus A. 4 marks. Let capital A, B, and C be the points with position vectors A vector, B vector, C vector respectively. Draw CD perpendicular to AB. Then area of triangle ABC is half base into altitude. AB, from which we have CD equal to twice delta area of the triangle ABC by AB, which is equation 1, where delta is the area of the triangle. Now delta equal to half modulus into modulus of AB vector cross BC vector, whose respective values are twice, implies twice delta equal to modulus of B minus A cross C minus B, whose expansion is this. Also, AB equal to magnitude of AB vector, which is equal to B minus A, modulus of B vector minus A vector. From 1, CD equal to, put the respective values, we have this. Question number 29. Using elementary transformations, find the inverse of this matrix. 6 marks. Let A equal to IA, where I is this. A remains unchanged. Interchanging first row and second row, we get this. For first row the 3 na puriraga, third row dagi khaidoga, we get this place is also 0. Similarly on the right side, again 0 1 0 1 0. Second row da 5 na puriraga, third row da hapsilu, we have this determinant, this matrix. Again 1 0 0 1 0 2. Divide 2 in each term of the third row, we have this equation 1 0 0 1 0 1 0. Third row da 3 na puriraga, first row dagi khaidoasi, we have 0. Again second row da 2 na puriraga, first row dagi khaidoksi, we have this matrix. Then product of these two matrices gives an identity matrix. Therefore, A inverse is this matrix. Question number 30. So that the right circular cone of maximum volume, which can be inscribed in a sphere of the radius A, has its altitude equal to 4A by 3. Radius A oiba sphere amagi manungda yauba maximum volume gi circular cone adugi altitude adu 4A by 3 oigani utlu 6 marks. Let A, B, C, D be the cone inscribed in a sphere of radius A and center O. Let B be the volume of the cone and O be equal to X. Then B is 1 by 3 pi r square into altitude. Altitude is A plus X. And multiply these two factors, we have this. Therefore, dB by dx, differentiating both sides with respect to x, we have this. Again, differentiating both sides with respect to x, we have this. For maxima or minima, we have to put dB by dx equal to 0. We have this. And factorize and solve x equal to a by 3 or minus a. Therefore, x equal to a by 3, since x equal to minus a is invalid. X cannot be negative number. When x equal to a by 3, the value of second order derivative is automatically a negative number, that is less than 0. Thus, B is maximum. Volume is maximum when x is a by 3. That is altitude, which is equal to a plus x. X is a by 3. Sum up, we have 4a by 3. Hence proof. Question number 30. A square piece of tin of side 18 cm is to be made into a box without top by cutting a square is from corners and folding up the flaps to form the box. What should be the side of the square to be cut off so that the volume of the box is maximum? Find the maximum volume, also 6 marks. 18 cm na side amagi asang oiba square gi tin gi square sheet amadagi corner sing the square gi pieces manaba pieces sing kakthatlaga lemhoriba kano sing no kong khatlaga lemhoriba saruk sing no kong khatlaga mathak hangdo pa box ama sengbadabani maximum volume oinenabagi damak aduga kakthat kadaba square size sing adugi asang ba kaya oigadage aduga adumna phangakpa open top yaudaba box adugi volume kayano adusu puthu. Let x centimeter be one side of the square to be cut from each corner of tin. Let B be the volume of open bin. Then volume is equal to 18 dagi x ani lokthokadi 18 minus twice x. Ani gi producti amadi square karani, then height to the x orani. We have this, expand and multiply. Now B is function of x only. We have to differentiate B with respect to x. We have this, again differentiating this with respect to x. We have d square B by dx square equal to this. For maxima or minima, we have to put dB by dx equal to 0. We have this quadratic equation in x. Factorize and solve x equal to 3 or 9. X cannot be 9. X equal to 9 is impossible. Therefore, x should be 3. When x equal to 3, the value of second order derivative, which is a negative number, that is less than 0. Thus, x equal to 3 is a point of maxima. Hence, the side of the square to be cut off is 3 cm and maximum volume is 18 into 2 into 3 whole square into 3. That is 432 square cubic centimeter. cubic centimeter. This should be cubic centimeter. For question number 31, prove that integral of 1 by root over a square minus a square dx is sine inverse of x by a plus c, and deduce that integrand of square root of a square minus a square dx is x into square root of a square minus a square by 2 plus a square by 2 times of sine inverse of x by a plus c. Modulus of x should be less than or equal to modulus of a 6 marks. We have to put x equal to a sine theta, and its derivative is dx equal to a cos theta d theta. Put their respective values, and taking out a from a square from square root, we have a. Cancelling these two, a and 1 minus sine square theta is cos square theta. Cancelling square root with square, we have cos theta. Cancelling again cos theta, we have d theta, whose integrand is theta. Now plus c, theta is equal to sine inverse of x by a. First part is over. For second part, also I equal to this. We have to apply integration by parts. This should be first function is the square root of a square minus x square. Second function is 1. That is first function unchanged into integrand of second function minus integrand of derivative of first function and derivative of second function, that is 1. We are ended with the x, whose integrand is x. Therefore x into root over a square minus a square minus x, whose integrand is x, and whose derivative is 1 by twice root over a square minus a square into minus twice x into x. Completing a square, putting a square minus a square minus a square, divide by denominator. We have put this by this, we have this by this, we have this, which is equal to I. Transfer this I on left side, we have twice I. This remains unchanged, whose integrand is sine inverse of x by a plus constant. Therefore I equal to divide in stem by 2. We have constant by 2 is we have put c. Question number 32. Evaluate integrand of log of 1 plus x by 1 plus x square dx from 0 to 1. 6 marks. We have to put x equal to tan theta, whose derivative is dx equal to sec square theta d theta. So that x equal to 0, 1. In that case, theta should be 0 pi by 4. This 1 plus tan square theta is sec square theta. Cancelling these two terms, we have this, and again apply this property. We have 0 to pi by I. Log of 1 plus tan theta plus log of 1 plus pi by 4 minus theta d theta. For this we have this, for this we have this. Simplify these two. We have this, cancelling these two factors. We have lastly we have log 2, and whose derivative is theta, that is pi by I. We have this. Question number 32. Prove that integrand of log of sin x dx from 0 to pi by 2 is equal to minus pi by 2 log to 6 mark. Let I equal to this. Also I equal to, applying 0 to a property, we have sine of pi by 2 minus x. Sine of pi by 2 minus x is cos of x, which is equation 2. Adding 1 and 2, we have on the left side is twice I, and taking this limit, we have log of sine x plus log of cos x, and we have log of sine twice x minus log 2. We have this, and for log 2 we have taking out log 2, and integrand of the x is x. Put twice x equal to theta in the first integrand, we have this. In that case, limit also change, is this by this rule. We have for this pi by 2 log 2, pi minus pi by 2 log 2, and this is also equal to I minus pi by 2. I cancelling, we have I equal to minus pi by 2 log 2. Therefore, whose value is this? 33. Find the image of the point with position vector this in the line this. Find the image of this point, position vector with respect to this line. Image of this point is this point. This is P, this is object, this is the image. Image is perpendicularly bisected. Let B x1, y1, z1 be the image of the point A with position vector A equal to this in the line this. This is the line, this is the given point, and this is the image. The position vector C of the midpoint C of AB is given by C equal to A plus B by 2. Using midpoint formula, we have this. Lastly, we get this. Since C lies on the line represented by equation 1, we should have C equal to this equal to this. For some lambda equal to R, belongs to R. Therefore, twice C equal to, multiplying on both sides by 2, we have this. These two are equal, therefore these two must be equal. Therefore, this equal to this expression. Equating coefficients of I cap, j cap, k cap on both sides, we have these three equations. Solving x1, y1, z1 in terms of lambda, we get this equation 2. Since AB is perpendicular to equation 1, AB, this line is perpendicular to the given line, therefore their dot must be 0. Put the value of AB, we have this, and for this we have this. Apply scalar product rule, we have this. We have this. Lambda x की वैल्यू थमो, y की वैल्यू y1 की वैल्यू थमो, z1 की वैल्यू थमो, lambda की वैल्यू खतंग सॉल्व तौसी, lambda की वैल्यू -1 फंग by 2 अदुदी x1 सॉल्व तौरे -3, y1 सॉल्व तौरे -2, z1 सॉल्व तौरे 1. Hence the required image is b -3 -2 1. Question number 33. Or find the distance of the point 2, 3, 4 from the line this measure parallel to the plane this. Distance of this point from this line measure parallel to the plane this. 6 marks. The given line is this is fraction equal to RC. Any point on this line is x plus by 3, x plus 3 by 3 equal to R. We have x equal to this. Again, y minus 2 by 6 equal to R gives y equal to this. Similarly, z by 2 equal to R gives z equal to twice R. Let the line passing A parallel to the given plane this meet at the point this point for some value of R. Then AB is perpendicular to the normal to the plane. This AB is perpendicular to any normal on this plane. So their scalar product means 3 to 2. Direction ratio 3 to 2, and whose direction ratios are this number, their product, sum of their products must be 0. From which we have to solve R. R is 1. Therefore B becomes, put R equal to 1, we have this, R equal to 1, we have this, R equal to 1, we have this. The required distance is distance between the given point A and point B. Using distance formula, we have the distance between the distance is square root of 33 units. 34. A housewife wishes to mix up 2 kinds of food X and Y in such a way that the mixture contains at least 10 units of vitamin A, 12 units of vitamin B, and 8 units of vitamin C. The vitamin contents of 1 kg of its food is given below. Food XY, vitamin A, vitamin B, vitamin C respectively. 1 kilogram of food X costs ₹6 and 1 kilogram of food Y costs ₹10. Find the least cost of the mixture which will produce the desired diet. Solve the LPP graphically. Graph paper will not be supplied. Housewife amana food X amasung Y haiba sinjak makhal anikak mix tauningi. Adugumba mix aduda yamdrabada vitamin A gi unit 10 yahonba, vitamin B gi unit 12 yahonba, vitamin C gi unit 8 haiba sing yamdrabada yahongadabani. ꯍꯥꯏꯔꯤꯕ ꯆꯤꯟꯖꯥꯛꯁꯤꯡ ꯑꯁꯤꯗ ꯌꯥꯎꯕ ꯚꯤꯇꯥꯃꯤꯟ A, B, Cꯒꯤ ꯌꯨꯅꯤꯠꯁꯤꯡꯗꯨ ꯃꯈꯥꯒꯤ ꯇꯦꯕꯜꯗ ꯄꯤꯔꯤ. ꯐꯨꯗ X ꯑꯃꯒꯤ ꯃꯃꯜꯅ ꯂꯨꯄꯥ 3ꯅꯤ. ꯐꯨꯗ Yꯒꯤ kg ꯑꯃꯒꯤ ꯃꯃꯜꯅ ꯂꯨꯄꯥ 10ꯅꯤ. ꯆꯤꯟꯖꯥꯛꯁꯤꯡ ꯑꯗꯨ ꯄꯩꯁꯥ ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯆꯪꯍꯟꯗꯅ ꯑꯄꯥꯝꯕ ꯅ꯭ꯌꯨꯇ꯭ꯔꯤꯑꯦꯟꯠꯁꯤꯡꯗꯨ ꯐꯪꯍꯟꯅꯕꯒꯤꯗꯃꯛꯇ ꯈ꯭ꯋꯥꯏꯗꯒꯤ ꯌꯥꯝꯗꯕ ꯄꯩꯁꯥ ꯑꯗꯨ ꯄꯨꯊꯣꯛꯎ. ꯒ꯭ꯔꯥꯐꯀꯤ ꯃꯇꯦꯡꯅꯁꯨ ꯁꯣꯜꯕ ꯇꯧ. ꯒ꯭ꯔꯥꯐ ꯄꯦꯄꯔꯗꯤ ꯄꯤꯔꯣꯏ. ꯑꯍꯥꯟꯕꯗ identify the decision variable. Let X and Y be the number of kgs of food X and Y. Then Z be the minimum cost of the mixer. Then the problem is to minimize Z equal to 6x plus 10y. Subject to the constraints, vitamin A gidamakta 1 into x plus twice y, which should be greater than equal to 10. And for next, the 2x plus 2y, which should be greater than equal to 12. After simplify, we get x plus y greater than equal to 6. Similarly, 3x plus 1 into y should be greater than equal to I. And xy is greater than equal to 0. We have formulated. The graphs of the equation x plus twice y equal to 10, that is x by 10 plus y by 5 equal to 1. X plus y equal to 6, that is x by 6 plus y by 6 equal to 1. Thrice x plus I equal to I, that is x by I by 3 plus y by I equal to 1. X equal to 0 and y equal to 0 are the lines A, B, C, D, E, F, y-axis and x-axis respectively. The shaded region A, P, Q, F with vertices A 10, 0, P 1, 5, Q 2, 4, F 0, I is the feasible region. P and Q yu points adudi coin solve toraga phamani. At A, Z, P and Q di line and isibu represent by equation and to solve toraga phamani. Sigi Q asisu line and isibu represent by equation and is solve toraga phamani. Hariba point P A, P, Q, F hariba point singa coordinates singa Z की value the sinjalaga, we get at A Z equal to 60, at P Z equal to 56, at Q Z equal to 52, at F Z equal to IT. Which one is the minimum least? 52. Thus, the least cost of the mixer is rupees 52 when number of kgs of food X is 2 and and that of Y is 4. Question number 35. An urn contains 5 balls. 2 balls drawn at random from the urn are found to be white. Find the probability that all the 5 balls in the urn are white. Patra amada ball manga yawi ball ani khak laukhatle angauba ngakta oina thenare. Find the probability that all the 5 balls in the urn are white. Patra adu yawiba ball pumnamak ado angauba oramba yai, mix oramba yai, angauba khara atu masusung yaramba yai. Angauba ngakta oigani haibagi chance putu 6 marks. Let H1, H2, H3, H4 be the events that the number of balls in the urn is 5, 4, 3, 2, respectively. 5 balls ni. Be the events that the number of balls in the urn is 5, 4, 3, 2, respectively. 5 balls shall we? 2 balls lokat pani. Let E be the event that the 2 balls drawn are white. Now, white or having event to the clearly H1, H2, H3, H4 are equally likely mutually exclusive and exhaustive. Then P of H1 H1 asidi number of events that number of balls in the urn is 5. 1 by 4 makoy khudingma patra balls in and uncounted 5 balls among lokapagi probability is 1 by 4 ngakani. P of E by H1 5C2 by 5C2, that is 10 by 10. P of E by H3 4C2 by 5C2 is 6 by 10. Similarly, P of E by A3 H3 equal to 3C2 by 5C2, so on. Required probability is P of H1 by E, whose formula is using Bayes' theorem. Putting their respective value and simplify, we get half. Thanks for watching.